Hi there, this is Dr. Everybody with Project 5, and in this one we're going to do a little bit of simple cryptography using the Caesar cipher. This is the one that Julius Caesar used back 2,000 years ago to communicate across great distances. And it's a relatively simple one, and what we're going to look at is how do you crack it. So if I'm given a code, how do you go about finding what the shift is that's necessary to crack this code. And the way we do it is we know that the most common character in the English language is the letter E. So we go through and find the most common character in the text and guess that it's an E, and you figure that shift and then try to decode it. And we look at it. If we could read it, then we got it right. If not, like maybe it's a short piece of encrypted text, maybe E isn't the most common one. So whatever character we tried first as the most common, we ignore that and then go on and try the next most common character and keep doing that until we find something that's readable. So it takes human interaction in our case to look at the result and see if we end up with English. So let's take a look at this. The basic idea is, as is shown in this diagram, is that all we're doing is a simple shift of the characters. So in this case, if the cipher has the letter D, then that really means it's the letter A. If it's an E, it's a B, and so on down. So in this case, if the letter H is in the cipher, it's the most common one, we guess that it's an E. That's a shift of 3. And whether it's a positive 3 or a negative 3 is not well defined in terms of Caesar ciphers, so we define it in a particular way in the function below. But it's just a simple replacement as we go along. So for example, if you see the cipher text with a W, then you look at the W and you see what's the corresponding one, and that's a T. And so there's how we get the T. And the same thing, the K maps into the H maps into the E, which we've already seen. You know, the T and the Q. So for example, there's the T, there's the Q. You got to be a little careful here. In the font that I use is not equally spaced, so I and J sort of, you know, mess it up a little bit for these characters in terms of them being right above each other. But the shift in terms of the number of characters across is consistent. So really the key ends up being, how do I find what the shift is? And you know, that's what the key is. So what is the shift of characters to get between my plane and my cipher? And when you're encoding it, you go you shift one way. When you're decoding it, you shift it back the other way. And to make life a little easier for you in this project, well, first of all, we do give you the algorithm. We input a cipher test, find the most common character, and then find the shift to get to that character, and then try and decode it. And as I mentioned, just stop at that point to get this part working, and then you can go on and do the rest of it. So and the other thing we do to hopefully make this a little bit easier is we define the functions, and we give you some code that has the functions. So you know, it doesn't have the guts of the functions, but it has the stubs of the functions. So for example, the first one is to get a character. It takes two things, a shift and a character in the shift. So for example, if I give you the shift of -3, and this is what you got to be careful of because that's the way we defined it, and the character H, it will return the character E. All right. And so we're calling that a negative, a shift of -3. So now this actually is the encoding and the decoding, depending on whether you use a +3 or a -3, or whatever shift that you give there. And you can write and test these functions one at a time. In fact, it's really the only sensible way to do this. That's the simplification part. Do these. Write this function, get it working before you try anything else. It turns out that actually this function, the outputting the plain text, is actually the next easiest one, and it's a bunch of calls to the get character function. So you just loop through the text, keep calling get character to decode it, and so you're given a cipher text as a string and a shift, which really is the key to the encryption, and then you output the plain text. And then this this function, the get the shift, this is the one that really cracks the code, in the sense that we want to find the most we want to find the shift, and we do that by finding the most common character and in the ciphertext. And now guess that it's E, and that guess is our shift that we determine. And then, and that's really the first part of it. And so the very, when you first write this, just ignore the ignore part. Just leave it as an empty string or something, and go ahead and get the whole program working, and then come back and handle the ignore part. And what the ignore, the way that comes into play is, if when I'm trying to decode this, the most common character, it turns out, is not the E, then I end up with garbage when I try to decrypt it. So I will ignore whatever character that was, and then say, well, maybe the next most common character maps to the E, and continue on that way. And then there'll be a main program which sort of drives this thing, calling these particular functions. So what we hope to do with this project is, well, first of all, we give you a start on it by giving you stubs. And so we say, okay, so you have to write a get character function, and it takes a character and a shift, and it's like, okay, remember, you got to put a doc string in there, and just so that this code will actually run and do nothing, a function has to have an instruction, and so we put this special statement in there that that's just a placeholder. So this program will run. It won't do anything because every one of these has a pass in it. So your job is to replace that with something that does whatever we specified. So what you do is you write this function first. Ignore everything else. Just write that function, and then you can go to the function test that we have and run that. And that runs runs 5 different tests on that function, and you can see how it went. And once you get that working right, then you can move on to the next one. And I suggest doing the output plaintext function next, and that is tested by test 3. And so in that we have, in that test, there is there's a string to be decrypted, and we provide the shift because that's been calculated by another function, and then we call this program with that string and the shift, and it should, when it's working, come out. So if I run this test, we see that we get a sentence that we can read, and if you look at it, there's a lot of E's in there, and that's why I made up that silly sentence so we'd have something to test. And then the third function, it starts with a string and says, okay, calculate the shift. And so we calculate the shift, and then the second part here is I actually give you something to ignore, and then we'll run it again. So we test it with with no ignore, and then with something to ignore, and of course you come out with with, oh, okay, the first time I'm the maximum character was J, and so that meant the shift was -5, and then I said, okay, let's ignore that J. The next most common character is Y, so the shift is 20 in that case. But notice you can write each of these functions independently before you go on and write the main part of the program. And none of these functions are all that long. So get each one working well, and then the final piece of this is the main part of the program, and that gets called down here. And there's this weirdness in here with respect to the calling of the main, and what that does is that actually lets us run those function tests. And basically what it says is if you import it, don't run main. That just lets us cleanly test them. And of course there are the other tests that test the entire program, and you need to uncomment this so that they look nicely when you do that, and that's the run file stuff that we've had before. So that's kind of an outline of how to approach this. My functions were all quite small. I think my getCar function might have had 2 or 3 lines to it, and the output, the plain text, oh, that's just a loop that keeps calling the getCar function. There's a couple of little things in there that you gotta deal with, like how do you handle spaces and punctuation and stuff like that. But not a whole lot of complexity to it. So in some sense, getting the shift is the hardest function. So do it last, and then once you get those functions working and tested, then you can write the main function, which it'll ask you to input something. You'll get the shift, and then you'll output the plain text. And if you can do this in pieces, you actually have a program that you can put together relatively with a limited amount of complexity, because we've broken the complexity down into these functions, and you can knock those off one at a time. All right. Good luck with that.